Assalamualaikum and good day everyone. For this video, kita akan masuk chapter 2 Atomic Structure, and for chapter 2 kita ada 3 subtopik. The first one is Bohr's atomic model, and then subtopik yang kedua 2.2 quantum mechanical model, and then 2.3 electronic configuration. Okay, here are the history of atom, theories and models. Okay, so as you already learned before this, you have learned about John Dalton, J.J. Thomson, Ernest Rutherford, Niels Bohr and Erwin Schrödinger. Okay, so all of these scientists, they propose an atomic model or atomic structure and based on few assumptions. Okay, so for our subtopic 2.1, we will focus on Niels Bohr atomic model. Niels Bohr, he proposed an atomic structure that is used to explain the formation of line spectrum in hydrogen atom. He believed that electrons are moving in circular orbit. So electron move in circular orbit around nucleus. Nucleus yang bahagian tengah ni. So nucleus consists of proton and neutron. So electron yang warna hijau ni dia akan circle around the nucleus dalam orbit. Okay, just like planets orbiting the sun. So Niels Bohr, he proposed the atomic model based on few scientific assumption, or we call it as postulate. So ada beberapa postulate yang kamu kena tahu. Postulate number 1. So electron move in circular orbit around the nucleus. These circular paths are known as energy level. Postulate number 2. Energy of electrons are quantized, which means it is fixed, determined by the quantum number n equals to 1, 2 and 3, any integer. An electron is neither absorbed ataupun dia tak akan absorb ataupun radiates energy if it is in fixed orbit. Okay, so kita boleh cari energy at that level for that electron. Contoh n equals to 1. Okay, so kita boleh guna this formula, En equals to negative RH 1 over n to the power of 2. Masukkan dalam formula, n tu kita masukkan value at that specific level. Contoh sekarang n equals to 1. So masukkan dalam formula to find energy at that level n equals to 1. Postulate number 3, the keyword absorbed and excited. So when the electron absorbs enough energy, it will be excited to a more energetic level ataupun higher level. So electron akan excite to higher level. So contoh ni n equals to 1, excite pergi n equals to 2. This process is called as excitation. Postulate number 4. Electron bila dia dah excited state, it is unstable. So, dia akan fall back, dia akan jatuh balik to lower state ataupun ground state. So, n equals to 2 tadi, dia akan jatuh pergi n equals to 1 dan dia akan emit energy, dia release energy dalam bentuk photon ataupun light. So, what is ground state? It is the state at which the electron have the lowest energy. Okay, so untuk ground state, dia tak semestinya n equals to 1. Okay, dia boleh jadi n equals to 2, 3, 4 and 5. Okay, so dia tak semestinya wajib n equals to 1 lah. Okay, it can be at different level. Okay, depends on the lowest ataupun on their lowest energy. And nanti kamu akan tengok ada 5 series. Okay, yang kita akan belajar series of hydrogen spectrum. Alright, so the next terms is excited state. So for excited state, it is which the electron have shifted from a lower level to higher energy level. So ingat excite, naik atas. And energy level, it is the energy associated with a specific orbit or state. So ini dalam bahasa Melayu kita panggil peta lah. Okay, so itu adalah energy level. Right, so for energy of an electron, okay, so energy of an electron in its specific level, okay, so kita boleh kira dengan menggunakan this formula. Okay, for this formula, it is En. E means energy and at specific level. So this formula, this is the first formula yang kamu jumpa. So this formula adalah untuk cari energy at specific level. So, contoh kalau soalan ditanya energy at n equals to 2. Okay, so you can use this formula. For this formula mesti ada negative. RH ni pula adalah Rydberg constant, and ini kamu boleh dapat daripada list of constant. Okay, so the value is 2.18 exponent negative 18 joule, and since kita nak cari energy, so make sure you use unit joule. Okay, Rydberg constant unit joule. N is the principal quantum number, ataupun tadi kita dah belajar energy level. Please take note that N determine the main energy level. Energy is 0 if the electron is located far from the nucleus. Kalau lah elektron tu jauh daripada nucleus, energy tu adalah 0. Okay, so maksudnya semakin menjauh daripada nucleus, the energy will become lesser. Okay, so energy associated with force of attraction are taken to be negative. So maksudnya you see the sign negative. Okay, so negative means ada forces of attraction. So forces of attraction ni between siapa? It is between electron and nucleus. So radiant energy emitted when the electron move from higher level, so ini higher level, drops pergi jatuh kepada lower energy level. So kita akan release energy sebagai photon ataupun light. Okay, so bila kita nak kira dia punya perbezaan energi or delta E, kita perlu ada dua value, energy at level 5 dan juga energy at level 2. So kita boleh kira dengan guna this formula. Nak cari delta E, perbezaan, beza mesti kena tolak. So kita tolak nombor besar, tolak nombor kecil lah. And E final, contoh, tolak E initial, energy for the initial. And then if you use this basic formula yang daripada the first formula yang kamu belajar before this, En equals to negative RH 1 over n squared. Okay, so kamu cari setiap level, tolak, and then dapat jawapan. Okay, so itu dia punya formula here. Okay, but you can rearrange. Okay, kita boleh rearrange. Ini kan nampak complicated kan, so we can rearrange to this formula highlighted in this box. Okay, so for this formula, ini adalah yang kedua kamu kena hafal. Alright, so remember to find difference in energy, kita guna formula ini, delta E equals to Rydberg constant, okay, times with Rydberg constant ni adalah 2.18 exponent negative 18 joule, and times with 1 over n initial to the power of 2, okay, minus 1 over n final to the power of 2. Okay, so kenapa tulis initial final? So from the given information, kamu identify siapa final And siapa? Initial. Okay, so remember, initial dia dari mana? So initial means dari higher level, from higher level. So dari sini initial, okay, jatuh kepada this n equals to 2. So ini adalah dia punya final ataupun dia punya ground state lah. Okay, so bila kamu masukkan dalam this formula, okay, dia akan jadi n initial 5 to the power of 2 minus 1 over 2 to the power of 2 in this case. Okay, bila masukkan dalam formula, kamu akan dapat jawapan untuk delta E berapa. Okay, and remember, delta E sini kamu akan dapat jawapan dalam negative value. And jangan lupa tulis unit. Okay, alright, so mana kita nak dapat Rydberg constant tadi? From the list of constant value, cari Rydberg constant here. Okay, kalau tak ingat, tengoklah formula, ada RH ni simbol dia. And then ada dua pula dekat sini. So the first one, 1.097 exponent 7 per meter. And then the second one is 2.18 exponent negative 18 joule. Okay, satu unit per meter, satu lagi unit joule. So remember, ini kita akan guna later on bila kita guna formula 1 over lambda. Okay, kalau joule kita akan guna dalam this formula delta E. So please take note this thing. Okay, sebab tu bila kamu buat calculation, penting untuk kamu tulis unit supaya kamu tak salah guna value ataupun substitute value. Right, so and then from this list of constant juga, nanti kita akan tengok, kamu akan jumpa Planck constant. So Planck constant 6.6256 exponent negative 34, unit dia joule second. Okay, so every time kamu buat calculation, please write the unit. Okay, and then kamu akan jumpa juga dalam this chapter speed of light. So ini kamu familiar, dalam fizik pun ada. So ini speed of light, C simbol dia, and the value is 3 exponent 8 meter per second. Okay, so bila kita dah cari delta E, the relationship is delta E is equal to Planck constant H tadi times frequency. So the Planck constant is 6.6256 exponent negative 34 joule per second. Okay, as we see here, Planck constant tadi sini. Okay, so always refer to your list of constant for the value lah. Okay, kalau tak hafal pun tak apa, every time nak buat calculation, refer to the list. And then frequency, bila kita dah ada delta E, dah ada Planck constant, kita boleh cari frequency dengan cara rearrange the equation. Ataupun sebaliknya lah, kalau ada frequency, okay, Planck constant boleh cari dari list. And then kalau nak cari delta E, so boleh masukkan dalam formula. Okay, so a photon of energy is emitted in the form of radiation with appropriate frequency and wavelength. Okay, so kalau nak cari wavelength pula daripada this relationship, kita boleh tengok sini. Okay, contoh kalau ada delta E dan kamu nak cari lambda wavelength. Okay, so terus guna this formula pun boleh. Okay, ataupun kamu boleh guna this formula dulu and then rearrange masuk dalam this formula lambda equals to C over V. So whichever method pun boleh lah. So ini adalah formula yang ketiga. Ini yang keempat kamu kena tahu. Okay, either one lah, salah satu, sebab dia benda yang sama sahaja. Okay, now let's have a look at this figure. Okay, so ini yang hitam ni adalah nucleus, and n equals to 1, the first energy level, n equals to 2, 3, 4, Okay, so itu adalah dia punya energy level. Okay, let's say elektron daripada n equals to 1 ni. Okay, dia orbit around the nucleus, and then bila ada energy, dia akan absorb energy and excite to higher level. Dia naik, excite pergi higher level, which is sekarang dia berada dalam n equals to 3. Okay, so bila dia dekat n equals to 3, it is unstable, so dia akan fall back pergi a lower ground state. Okay, so electron that is excited from lower to higher energy level, a specific amount of energy is being absorbed. Delta E equals to energy final tolak energy initial. Okay, and ini adalah energy being absorbed. Okay, so kalau absorb memang akan dapat positif. Okay, tapi kita nak fokus dekat energy being released. It is when electron dekat higher level drops to lower level, so dia akan release energy in form of photon. Electron falls from higher to lower energy level, so photon is released. Okay, dia menghasilkan photon. So macam mana kita nak kira this delta E? So ini yang kamu kena fokus dan highlightkan lah. Delta E equals to energy final tolak energy initial. Okay, ataupun kita akan guna formula tadi. Delta E equals to Rydberg constant times with 1 over n to the power n initial to the power of 2. So contoh kalau initialnya dari ini adalah n equals to 3, dari n level ketiga drops pergi 1. So initialnya dari 3 drops pergi 1. 3 to the power of 2, 1 to the power of 2, and then masukkan value RH and you will get delta E berapa. Okay? Okay, so let's have a look at this illustration. So sama juga macam tadi, cumanya ini dalam bentuk energy level diagram. Elektron, okay, so contoh dia berada di n equals to 1 level, n equals to 1. Okay, so bila ada enough energy, okay, dia akan, electron will absorb the energy, so it will excite to higher level. So bila dia dah dekat higher level ni at n equals to 3, okay, dia akan unstable. So what will happen? It will fall back, jatuh kepada lower level. Okay, so bila dia drops, electron from higher level drops to lower level, you will release energy in form of photon. Let's have a look at this example. So calculate the energy of an electron in the second energy level of hydrogen atom. So ini soalan dia minta specific energy at n equals to 2 berapa. Okay, so kita kena guna the first formula, which is this one, En equals to negative Rydberg constant 1 over n to the power of 2. So kita masukkan dalam formula at E equals to 2, so negative 2.18 exponent negative 18 joule times 1 over 2 to the power of 2, and your answer will be negative 5.45 exponent negative 19, jangan lupa tulis unit joule. Alright, so for example 2, calculate the energy of an electron in the energy level n equals to 6. Okay, so ni dia cakap mesti at n equals to 6. So sama juga, just masukkan dalam formula and gantikan this part n dengan 6, because you know that you want to calculate at n equals to 6. So your answer will be for the third example. So this question, you need to calculate the energy change. Energy change is delta E. Okay, so delta E mesti melibatkan ada dua N initial dan N final. Okay, so bila apa-apa soalan dia cakap change in energy ataupun transition, apa lagi dia guna perkataan transition of electron, mesti ada melibatkan dua level, N initial dan N final. The question said that the transition happen from n equals to 5 to n equals to 3. And then the second question, you need to calculate the frequency and wavelength. Okay, so for this question, since dia minta delta E, kita guna formula delta E dulu. And then from the delta E punya value, kita boleh cari frequency and also wavelength. Okay, so from here, the information yang kita ada, okay, labelkan dulu siapa initial. Initial dari mana? Dari atas. Initial. And then final, n equals to 3. Okay, dia jatuh kepada n equals to 3. Alright, so masukkan dalam formula. Rydberg constant 2.18 exponent negative 18. And then bahagian bawah ni, initial 5 to the power of 2 minus 1 over 3 to the power of 2. So, bila kita solvekan this, kamu akan dapat 1.55 exponent negative 19 joule. Okay, so jangan lupa negative. Okay, energy is being released. So, for question B, kita nak cari frequency and then kita cari wavelength. So, the relationship between delta E dengan frequency, delta E equals to Planck constant times frequency. So, to find frequency, kita rearrange this formula and then masukkan value delta E. So, delta E ni kita hanya ambil value sahaja. Tak perlu ambil negative sign. Okay, so bila kamu substitutekan dalam formula, kamu akan dapat begini. Your final answer will be 2.34 exponent 14 per second. Okay, units dia per second ataupun S-1 or can be hertz because it is frequency. Okay, next kita nak cari lambda juga. Lambda equals to speed of light divided with frequency. So, since kita dah ada value untuk frequency, kita boleh guna this formula and then substitute to get the answer. So, the answer in meter 1.283 exponent negative 6 meter. So, final answer will be 1283 nanometer. Ataupun kalau kamu nak tulis dia punya conversion unit, you can use this method or whichever method that you prefer. Okay, so you can use this method. 1 nanometer kamu tahu dia bersamaan dengan 1 exponent negative 9 meter. Okay, so here we have 1.283 exponent negative 6 meter. So berapa nanometer yang kita nak cari? So ini bahagi this two and then bila dapat jawapan darab dengan 1 nanometer, kamu akan dapat 1283 nanometer, the final answer.